Thank you, Chair. Good day to everybody, and thank you for the opportunity to share some experience from South Africa. Just a quick outline of what you will find in my presentation. Basically, I'm going to touch on two aspects. One, initially looking at the status and trends of in situ hydrological monitoring networks in South Africa, particularly because it does have some links to satellites and Earth observation requirements really from a national hydrological services in South Africa. I know a lot of the discussion so far today really focused on flood forecasting and the use of satellite products, which I think is quite important. But before we get into the details of satellite imagery, I think it's important also to understand a little bit about the history of hydrological observation networks, especially in the National Hydrological Services environment. What I have in front here on the screen is basically a trend analysis of in situ monitoring. I know a lot of the countries here today mentioned that limitations in data and actual in situ data is very crucial for validating, the results of the hydrological models, which are in a lot of cases using satellite precipitation as inputs. So if you just look at the trends for South Africa, there was quite a rapid growth in our in situ monitoring network up until the 1990s, and thereafter it's sort of the number of stations really reached an equilibrium really, so it's not really increasing that much. But all I can say for South Africa, we generally are quite data rich compared to other countries on the African continent, and that helps us really when it comes to calibrating our hydrological models, whether it's for water resource analysis or whether it is for flood forecasting purposes. This is basically one of our sites located on the Great Fish River in the Eastern Cape province. It's quite crucial, and I would like to use this particular case as an example to show how I actually use satellite data to improve the high flow rating curve for this particular structure. So what you see in front is a crumb structure, which in South Africa, we really have a lot of these artificial controlled structures. And the reason for this is for high accuracy of basically low to medium flows. And these structures generally have a limitation in terms of the discharge that it can estimate. However, we have to then apply indirect methods to be able to calibrate it for much higher flows. And, that's where the role of satellite data becomes important, where we can use data sets like digital terrain models or digital elevation models that can give us good ideas of the floodplains. And that's quite crucial when you're trying to estimate a high flow. So certainly satellite applications have played quite an important role. So basically for that particular structure, we set up a hydraulic model. If you look on the screen, if you go back into history, we never had the luxuries of satellite precipitation looking at extent. So what was done back in the day was flood marks were basically picked up by people and then surveyed. And, that information was quite crucial when we then did the flood modeling to determine, what is the discharge at the particular monitoring site. And then we could use that discharge value to have more confidence when we are extending the rating curve. So this was basically the results from that particular analysis. We're able to extend the rating curve. And, I know a lot of applications are on flood modeling, and no doubt in South Africa, we are doing that. And you'll see from my slides that are coming. But it also shows that even in situ monitoring, satellite data can be quite crucial. However, one of the biggest challenges that we face, and I don't think it's just South Africa, I think is abroad, is really access to high resolution digital elevation models. It's definitely not open source at this stage. I think from some of the presentations that I heard earlier, I think 12.5 meters was what was being used. And this data doesn't really capture the channel cross-section area. So, as a requirement for hydrological services, if we could get much higher resolution, open source data for channels, it would greatly improve our ability to rate our structures or rate our monitoring sites for much higher flows. And so when we're doing the hydrological modeling, we can then get better results, especially in the high flow range. So this was a particular model that was set up, which we are currently setting up, HMS for the Vaal River system. Also quite a complex system with basically two dams, one being the upper dam, which we sort of use for flood attenuation. It's gated. But I mean, without satellite products and inputs, we would spend hours delineating catchments, determining river lengths and so forth. So from a hydrological services point of view, the value in the satellite products is it's ranging from digital terrain data to satellite precipitation data to various other products like we've seen earlier, soil moisture and so forth, that help us to better understand, the hydrological processes in the catchments. This is another example from South Africa where it's actually transboundary river basin. It's the Limpopo River Basin cutting across Botswana, contributions from Zimbabwe, South Africa, and actually the impact mainly felt in Mozambique, which is the outlet. The upper countries is where the runoff is really generated. In this particular model, I think 3 gauging stations more or less were used to calibrate the model. In this case, like I mentioned, if there's no high resolution digital elevation data, then we have no choice but to look at a higher cost where you have to get actually drone survey done to bring in LiDAR data. So if we get more access to satellite data products, especially on the actual channel itself, that will greatly improve the modeling that we're doing. And so that if a flood forecasting system is developed, we're not giving bogus results and evacuating communities without having high confidence in the results. So yeah, I think it's going to take a both combination of satellite and in situ monitoring to develop a good solution in the space of flood forecasting. And yeah, we definitely need the satellite products. Sitting in the National Hydrological Services, you're not necessarily just a remote sensing specialist per se, but a lot of the focus in this environment is on the data collection at gauging stations. But I think there needs to be careful thought in terms of how we capacitate hydrological services to make use of the products that are coming out at lightning speed. Other stuff, maybe not so technically developed, is just just satellite imagery. Having good satellite imagery helps you to better interpret some of the plans. In a lot of the modeling, we may include a dam with gated spillways. Sometimes just looking at the plan doesn't give you a good idea of what the actual site looks like. So satellite imagery definitely just for screening and determining access routes, putting in plan data into models is quite useful. And I think, satellite providers are really showing us the high resolution that's coming out today compared to decades back. And yeah, it's just getting better and better. I guess as hydrological services, we sort of need to keep up. One more application that I'd like to touch on, I know time is limited, is network design. And I think for many countries, they're still developing their monitoring networks. This is basically a picture of the design monitoring network for South Africa. The network is redesigned, still very much in implementation. But without satellite data products, we would never been able to identify, where's the opportune site to monitor, which sites have accessibility, and things like that. So satellite products definitely influence the way in which we determine the design and our approaches towards network design. I think a lot of this has been covered, but I think from a national hydrological services, satellite imagery, more high resolution digital elevation models, as well as constantly getting better precipitation inputs at higher resolutions, better soil moisture products so we can model better, is definitely, things that National Hydrological Services need, to be capacitated. Thank you, Chairperson.